exact same goal we had yesterday. Let's take one more look at what that will look like when we achieve that goal. So you are going to have this sentence in English, and basically you are translating that sentence into the language of chemistry. You are changing our compound names into chemical formulas. You're changing our states of matter into symbols that we know either mean gas or aqueous or liquid or solid. So let's go ahead and get started with this. Not a whole lot of notes today, but I do want us to take down again what the term diatomic molecule means. So diatomic molecule, once again, means two atoms bonded together. What is our clue? And you can just shout this out. What is our clue that this term means two atoms bonded together?
Di.
Di, that prefix di. Excellent. Very nice. So, this will come up today because you will be asked to write formulas, and it might say gaseous hydrogen reacts with something else, reacts with methane. So gaseous hydrogen, we might want to write like this. But that's not how it is because hydrogen is diatomic. So how would we write this? H2. Very good. H2G. Very nice. So keep that in mind. On your periodic table, instead of writing these out in our notes, let's just mark them with a big star on our periodic table. So we have H2, N2, O2, F2, Cl2, on and on. And here's what it should look like on your periodic table. It looks like a big 7. Big 7. Okay, as you are doing that, I'm going to set up our document camera so I'll know that you are ready to move on when you have your note sheet flipped over and turn to the class example. Okay, I see Steph, she's ready. She has that note sheet flipped over to the class example. Oh, thanks for on it. On it. Okay, way back in the back. Can you see that, Fatima? No? Okay. Let's try.
I think I need to
Turn off the lights? Okay. Erica, would you mind grabbing one light, please? One? Yeah. We'll try one first. Two? Oh. It was kind of creepy, but now it's brightening up. Okay. All right. For this example, it's going to be a lot of me talking as I walk you through this process. I do expect that whatever I write, so whatever you see up here on the document camera, you also have within your notes. Let's go ahead and get started. Jennifer, could you read the class example out loud and then we'll get going?
Aqueous solutions of sodium phosphate and calcium chloride are mixed together. The result is the formation of solid calcium phosphate and an aqueous solution of sodium chloride.
Excellent. My very first step when I approach this problem is just reading it over. See if I understand it, and then we are going to go through and underline those necessary components that we need. So the very first thing that I underline is aqueous. So I have aqueous solutions of, good, I'm glad I see pencils moving with me, of sodium phosphate and calcium chloride are mixed together. The result is the formation. That word, formation, alerts me to something. Something's going on. I'm switching from my reactants to my products. So, formation, I'm going to put an arrow, then keep underlining solid calcium phosphate, aqueous sodium chloride. So now, just like we've done for other problems, we know what we're working with, we know where we need to go. So let's get started. Sodium phosphate first. Sodium What's my charge on sodium? You just shout it out.
1.
Plus 1. There we go. Phosphate, PO4 with what charge? Wait, try it again. -3, very nice. And how will I tell people that this is aqueous?
AQ.
AQ, very good, very good. So AQ. Then I add in calcium chloride. Calcium has a +2 charge, chlorine has a -1 charge. If I crisscross those charges, I have CaCl2, and it is also aqueous. And then I hit my arrow. So now I'm to the products. And I have solid calcium phosphate, so Ca with a +2 charge, phosphate, PO4 with a -3 charge. If I crisscross those, get Ca3, PO4, 2, and finally, my final product is sodium chloride, table salt. Na, +1 charge, Cl, -1 charge. Those cancel out, and that is aqueous. Let me zoom out a little bit so you can get that down on your paper. Whew, man, that was a lot of work. Do you see a problem, Jasmine? X. Very nice. Good. She caught me. So calcium phosphate is solid, so I do need to put that little S in parentheses. Steph, is that your concern as well? Good eye. All right. At this point, we're not done yet. What do we have to do to make sure we have the correct answer here? Balance this. Exactly. I am not going to take you through how to balance this. We know how to balance equations at this point. I will fill in these coefficients. So we would set up our table and we would go through it all. Our coefficients would be oh, you're setting up our table? I'm just going to tell you the coefficients. So let's just write those in. So we would have 2, 3, we have 2, 3, 1, and 6. 2, 3, 1, and 6. Okay. Next up, we are going to go into practice. So you get to try this out. The first 30 seconds, all I want you to do, to work with the person sitting next to you, is underline what you find important in the you try problem. So underline what you find to be important in the you try problem. Begin. 20 seconds. One S, 2 S, 2 P, 6. All right. Chlorine gas. How did you write that out for us, Cynthia? Cl with a -1 charge and a G. I like a lot of what you did there. You're missing a main point from today. Can you help correct her, Jasmine?
Chlorine is a diatomic ion,
Okay, so Cynthia, can you repeat that? What's wrong with chlorine the way we have it written right now? Not a polyatomic ion, a diatomic ion. Very good. So instead of just Cl, we need to have Cl